You can create an array that is effectively an array of columns and rows, a matrix. When we declare an array, we are basically declaring an array with one row and however many columns wide you made it. So let's say I need an array with 3 different batches of 4 different numbers. That would be an array of 3 rows and 4 columns. Written out as a spreadsheet that we can picture and understand, it would look like this. I can create this batch with a declaration like this. If it helps you to visualize it, this is also a valid way of writing that same code. So in my spreadsheet format, I included the array index of each element. Just remember they are 0 indexed. So I declared 3 rows and 4 columns. I have 3 groups, each containing 4 numbers. So to access the third element in the second group, otherwise known as the third column in row 2, I could lock and load it into a variable like this. Remember, 0 indexed. First you give the row offset, then the column offset. So after this instruction, extra number would equal 0 as it retrieved it from the array. So the compiler will simply set aside 12 memory locations. Basically, it'll set up 3 different arrays, the rows, each of which has 4 elements, the columns. Each row has its own initial address, which the program retrieves, and then it adds the index to offset the original memory address to access the number in the column memory. Hopefully this makes sense. Now, arrays are incredibly useful, but you might be wondering where on earth you would use them. Well, let's look to the future to simplify a really complex topic we're going to cover in Course 5, Autonomous Robots. This is where we try and give our robots decision-making capabilities for things like deep sea navigation or cave exploration, etc. One such method of navigation is called SLAM, Simultaneous Localization and Mapping. Let's use a very simple version of SLAM and store the data in an array so you can grasp how an array works in a practical way. Let's say we've got your googly-eyed mobile robot with an ultrasonic sensor mounted on a servo motor so that it can scan a complete 180 degrees left to right, measuring the distance to walls and obstacles, and building a map as it goes. So where it starts, we will designate that location as 0 on the x-axis and 0 on the y-axis. And our map is a real-life grid in centimeters. Now I've got the whole picture here on its side so we can see more on wide screens. So negative x is going up, positive x is going down, and positive y is going straight ahead from the robot, which is to the right in this picture. The robot will build what we call a point cloud by measuring distances to obstacles around it. You can see the room that the robot is in. Its outline is in gray. Now the robot does not know anything about its environment. It just got dropped into a random point and will now simultaneously navigate the room and map it. So as it scans around the room, it triangulates points all around it where it gets a reflection from the ultrasonic sensor. Each of these coordinates is stored in our master map array as simple numbers of x and y centimeters relative to our original starting point of 0, 0. Now, when the robot moves up ahead, say 20 centimeters, it can now perform some more measurements and add some points to the cloud exactly like it did before. The robot moved itself straight ahead and measured its movement so it knows where it is. It knows it is still at 0 centimeters on the x-axis, but now plus 20 centimeters on the y-axis. So it can triangulate all of these points again relative to its current position and add a whole pile of new points to the map, which it stores in the array. So it builds this array as it goes along, avoiding obstacles and mapping where all of the obstacles are. Now, as it tries to navigate back home to 0, 0 on the map, It can look for all of these points by measuring all around it and cross-referencing to the points stored in the array. It can both locate and verify its current position on the map and calculate the moves it needs to make to get back to the home position. Remember, microprocessors only deal in numbers, so the map is simply a multi-dimensional array. We can both write all those numbers and read them. Simple, huh? SLAM navigation is more complex than this, but this simplifies it all, and you can hopefully see an immediate use for arrays.